I thought I would do an update on a few things around the workbench, so I've gathered some parts here. Starting with this electronics magazine, Radio Electronics, from March 1989, where on the cover the main project was this Helium Neon laser high voltage power supply, the one that's based on a 555 PWM generator that pulses a transistor and a transformer to generate high voltage through this diode capacitor multiplier out through a ballast resistor to the helium neon tube. And I thought if I ever locate this, I will see if it still works. It doesn't. This is the condition I found it in. So here's my helium neon tube itself. Looks like they're saying it was a 0.6 milliwatt tube, and I guess this is a brand or a manufacturer or something, so I'm not familiar with that. But the high voltage probes would go on each end of this tube, and the tube would be strapped on to the power supply chassis on the side and shoot out a laser beam. So here's what's left of mine. There's parts everywhere. This was the caution label for the output section. So the wire would come out here. There's a part tray that I was looking for. It looks like this thing had some emotional problems and I was trying to counsel it at some point. I don't remember what's going on. It looks like I had test leads for those high voltage connections. There's the 555 circuit and the chassis, the transformer, and the power switch and the transistor. So looking at the evidence where the laser tube was tie wrapped onto here, it looks like this is cutting right through this double-sided foam tape, which really looks deformed at this point. It's not even on the chassis anymore. It looks like it slid up and maybe this chewed all the way through. I might have had some sort of a short circuit that blew an output high voltage diode or something. This vaguely rings a bell, so I'm not sure what's going on here or if it's salvageable. Maybe I'll try to troubleshoot it, see if I can get it working, but if not, it could be the tube. I did a little research and it's possible the tube is no longer any good if something, maybe a seal got broken or something like that. But I only have the one high voltage laser power supply and the one laser tube, so if I can't figure it out, I don't have anything else to do any troubleshooting back and forth. And these days, who needs a helium neon laser when there's so many laser diodes around? So this will have to get shelved. Also, at one point, I was trying to get one of these membrane keypads, row and column style matrix, working as an analog keypad where I could just have resistors and take one analog voltage, and depending what button you press, the analog voltage will tell you what kind of voltage divider you've mapped out and therefore what button you've pressed. And I could not get this to work reliably, so I thought I've also ordered another one, and maybe I'll try this and see if it was just a weird thing here. This also did not work reliably as an analog keypad. I had the same issue as I go along the rows or columns and I push a button and then measure the resistance across that row and column. I get different resistances. I don't know how these things are set up. I can't get it to work as an analog, so I'm going to have to stick with rows and columns. There are dedicated ICs that help offload a bit, where you can have an external chip with all the discrete rows and columns, and then it just sends out a 4 or 5 bit binary encoded version of what's being pressed. For now, trying to get these to work as an analog one-wire keypad, that's getting shelved. While looking through some more boxes trying to sort things out, I found some old supplies. A couple of these solder wick copper braids for desoldering, as well as a name brand flux pen. This one, unlike the ones on eBay, doesn't have a date on there for manufacturer or expiry, as far as I can see, so I'm not sure why the other ones do. This one from eBay labeled Kester, which I highly doubt. It says it was manufactured December 2017 and the shelf life is 1 year. So I wonder, is there really a shelf life or what's going on? I know these are totally different materials. This says 835p. I don't know, does that correspond with this being a 951? This one, it has a very heavy chemical smell. It's sticky. I tested it out and way too much came out of here. It went all over the board. And yeah, it is different. So next time I need to use flux, I'll try this one out. And these will go near the desoldering station. And finally, these vibration detector switches, SW18015P. These are the ones where there's one center post and then there's a thin filament spring coiled around it, and if this thing moves or detects any vibration, it'll close these two contacts. And that's kind of hard to work with on a breadboard. One's really thick, one's really thin, so I soldered on a couple of wires, made this thing breadboard friendly, and I'm going to test this out. And here is that reed magnetic switch interface module with the comparator and a digital output. And this had been smashed, so I hot glued it. I just held it in place, getting those terminals to overlap, and I just dabbed the glue to keep it there. It's not something I'm going to want to use permanently. I just wanted to experiment with it. So there's those two contacts. They're actually drifting apart again. They were more overlapping each other. It's hard to show. So I did the best I could and then dabbed this glue, and I want to try that out. Here I have a test circuit set up for these SW18015P. I have it hooked up to an oscilloscope like this, and I've chosen to have an artist's interpretation of an old vacuum tube style oscilloscope, but I don't have one anymore. So I'm using a battery pack with 3 AA's giving me 4.5 volts, and I'm breaking the positive rail with this spring vibration sensor, and then I just have an LED and a series resistor to ground, and I am probing off of the resistor. So when nothing's happening and we have an open circuit and the LED is off, I'm just measuring ground through this pull down, and when this receives a vibration and intermittently makes contact and lights the LED, I see just over 2 volts here, since we're starting from a 4.5 volt supply, and I'm not even sure what the actual voltage is because it's 3 AAA batteries that are not fresh. So we have an LED that's going to have a couple of volts drop, and then the rest is going to be on this resistor, so I seem to be measuring about 2.1 volts, I think, here. And I had to set this test circuit up because initially I just tried to measure continuity across here with the meter, and no matter what I was doing here to cause vibrations, I wasn't picking anything up. And the reason is the contact is so short duration, the meter can't register it in time, but we can see the blink and we can measure the time with the scope. So here's the battery pack with the on-off switch. And of course, I didn't have a convenient resistor on hand, so again I'm using this jumper surface mount resistor decade box to get me 300 ohms. And on this little breadboard I have the LED hidden down here. It's green, and all the wiring for everything. The scope probe is over here, and here is the vibration sensor. I soldered on 2 wires and used heat shrink to make this more robust because there's no way I could get that in the breadboard. So it's easier to see when the light's dimmer. The sensor is right here, so if I hit it, we should see the LED right here. And I can hit the breadboard, and these wires are very rigid, so it transfers the energy and still vibrates. But I can't really hit the table and make it respond. It's not that sensitive. So I can get a visual here, but I also have it on the scope. Right now the scope is showing 0 volts and it's set to trigger on rising edges, which is what will happen when I cause a vibration. So I'll just hit this momentarily. So I saw the light blink once with my vision, but I have a whole bunch of triggers here. There's a bundle of several triggers right here and another bundle right here. This is 200 microseconds per division, and the top voltage measured was 2.28 volts, as expected with the diode and the resistor. So 200 microseconds from here to here. It bounced around for about 300 microseconds several times in there, and then it bounced around maybe another 200 microseconds, and that was separated by about 600 microseconds. So I'll try to get a more clean bounce. There's one. So that one's pretty much exactly 200 microseconds. So that's the kind of time frame we're looking for, and the multimeter couldn't pick this up as a continuity, but the LED, you'll be able to see a quick blink. So that works. And here's that reed switch module with the comparator output that came with the broken glass reed tube. And it does work, but sometimes it sticks when the magnet goes up and it activates. I take the magnet away and it will stick. Other times it'll work fine, which is expected. I just wanted to get it put together for a little prototype, and when I do get the replacements in the mail, I'll use those. I don't have a schematic and I haven't traced this out. It's just a simple comparator, so I'm assuming this is just the threshold voltage setting. But does that really matter? We're just going to be switching from fully open to fully closed. We're not looking for an analog input to reach a threshold, so it's going to cross the threshold every time, right? So I tried adjusting this extremely low and extremely high. When I adjust it right down to the one side counterclockwise, the output waveform will go from completely high to about halfway down instead of all the way to low. So it's basically not functioning properly. And when I start turning it clockwise, it'll get to a point where the output is just going to be on all the time instead of just when we activate the switch. So it's kind of latched fully on or kind of fully off. And everywhere in between, it just works. So I've powered it up with the same 4.5 volt battery pack, and then it went to its default off state, which is a logic high out, and the only LED turned on here is the power light. To the left of it is going to be a light that comes on when the reed switch is activated by a magnet. So sometimes this will latch and stay on, which it's not supposed to do, but it's a hack. It's only temporary, and in fact, it just stuck a bit there. There, I mechanically nudged it and it got stuck in its on state. But the module does work, so when I get my replacement reed switch, we should be good. Oh, and I just used the power of moving air to clear the fault.